Right, we'll look at blackbody radiation today. So firstly, we're going to define what a black body is in physics. So in physics, we say a black body is something that will emit all of the radiation that hits it. Okay, every single bit of electromagnetic radiation that hits this object will be absorbed and then re-emitted. Okay, so it absorbs and re-emits all electromagnetic radiation that hits it. Furthermore, if you had an object that had a certain temperature, say, that object will emit across a range of wavelengths. Okay, and this is what we call a blackbody spectrum. So let's take, for example, say a lump of iron. Okay, so you've got a lump of metal iron. Now that lump of iron has got a certain temperature. It will emit across a range of wavelengths, and I've actually drawn a graph to represent this. Now a cool block of iron sitting on a table will emit a range of wavelengths across this smaller curve here, this small curve on the graph. Now at the minute, none of the wavelengths that it is emitting is in the visible light part of the spectrum. Okay, so it's not going to glow, but it's going to emit some in the infrared part of the spectrum because it's this part here is longer than the red part of the spectrum, so it's going to emit some in the infrared part of the spectrum and other wavelengths as well. And then I've got intensity up the side. Okay, so it's peaking around about here. So the peak wavelength that it's emitting is somewhere around here. So it's a fairly long wavelength. Now if I heat up the iron block enough, you know that it will actually start glowing red. Why is this? Well, when you heat up an object, it will begin to emit more wavelengths of electromagnetic radiation. So the range of wavelengths that it emits will increase. Okay, any wavelength that it emits in the shorter end of the spectrum, the intensity will increase more for those things. Okay, so shorter wavelengths, the intensity will increase more. What's that going to look like on a blackbody spectrum? So if I drew the curve here, it's going to peak. It's going to increase more for the shorter wavelengths, okay, and then it's going to spread out more as well. Okay, so this is warmer. Okay, so you can actually see now that some of the wavelengths, this part of the spectrum here, is actually in the visible light part of the spectrum, specifically the red part of the visible light spectrum. So this iron block now will start to glow red. So this is slightly warmer. You can see that the shorter wavelengths, the intensity has increased more than the longer wavelengths. Okay, it's also, because of this fact, it's also going to peak at a shorter wavelength. So the peak will shift to the left, it will shift towards a shorter wavelength. If I heated it up even more, then the shorter wavelengths will increase more, the range of wavelengths will get larger, so it will look a little bit like this. Okay, this time the peak has been shifted here, so this is a hot object. Now you can see here that it's actually starting to emit across the entire visible light part of the spectrum. Okay, so this object will actually start to glow white hot. It will glow white, yeah, because it's emitting all of the visible light wavelengths. Those are going to mix together to make white. Now it's actually emitting more red than it is violet, so it will be slightly sort of pinky red colour. It will look almost white. Okay, if I heated it up even more still, it's going to look something like this. Okay, so we've got the peak now is even more shifted over. This is really hot. Okay, and here we're talking about things like stars. Okay, stars are very, very, very hot. Okay, they're emitting across an incredibly large amount of wavelengths, and it peaks generally in the visible light part of the spectrum. Our sun peaks at about 500 nanometers, and as a result of that, our eyes have actually evolved to be able to see the visible light part of the spectrum. If our sun was peaking at longer wavelengths, then chances are our eyes will have evolved to see in the infrared part of the spectrum, and so on. Okay, so really hot objects actually peak in the visible light part of the spectrum. Some stars actually peak in the ultraviolet part of the spectrum. Those stars are incredibly hot. So the shorter the wavelength of it, the shorter the peak wavelength, the hotter the object is. Okay, right, that's blackbody radiation. I will see you in the next video.